Hi, this is Kevin Trainer. Welcome to part two of my tutorial for chapter three of the Zelle Python book. And in this case, we're going to be starting out with pseudocode for the program that we're going to create. So the program is going to be called Quotient Accumulator. Okay, and here's my pseudocode for it. All right. And let's see. I've decided I kind of like this idea for now of having comments in my pseudocode. It's kind of reminding me how I'm kind of um, organizing the program. And I can see that I made a mistake here. And this is it. Okay, so uh, what does this do? What are we doing in this program? Well, we're kind of doing what we did in the last one. We're doing integer division. Okay, so we're uh, we're going to prompt the user for the dividend and the divisor, and they're going to be ints. And then we're going to calculate the quotient. It's going to be an int. Okay. And then instead of just doing that one time, what we're going to do is we're going to do this in a loop. Okay. And it turns out we're going to do it 5 times. Okay. So this is a loop that goes around 5 times. Okay. And every time we go around the loop, we're going to print uh, what the quotient is for the number pair that we just got. Okay, but we're going to be accumulating the amount from each of the quotients so that when we're done, we're going to be able to say the accumulated sum of the quotients, let's say quotients, is, and then we're going to have a number. Okay, so I want to point out that we're actually following two patterns here. Uh, One is an almost universal pattern, input, process, output. Okay. And we're doing it inside of a loop. So we're getting some input, we're doing some processing, we're, we're we are putting out some output. It's almost like an intermediate output. It's not the final output, right? So we're going to go around the loop. And then when we're done, um, we're going to skip a line in order to separate this. And then we're going to print um, the accumulated output. Okay. And okay, I'm looking at my program and I'm seeing that there's one other part. So print message to say which pair of integers we are collecting. Okay, so we'll do that every time around. Okay. Okay, so I think we're pretty close to it here. Okay, so as is typical, I've got some variables I need to initialize. Okay. The accumulator pattern says we always have to zero out if this is an addition and subtraction accumulator, which it is, as compared to a multiplication one, which they show in the Zelle textbook. Um, in a typical addition and subtraction accumulator, we initialize it to 0. Um, we I want to be able to show in the program that we can do a loop on the basis of of an integer value that's in a variable. That's why I predefined that. So we're going to loop number of pairs times, number pair times. Okay, and then we're going to go around the loop, do input, process, intermediate output. Okay, and then in the end, final output. Okay, all right. So let's take this off of here and create our our code. So we want a new Python file. And I said I was going to call it quotient accumulator. Okay, no .py because that gets put there automatically. And we're going to start with a doc string, 3 double quotes, and it puts in the terminal ones. And what do we want to do? Well, we're trying to demonstrate something. We've got integer division, okay? So we're demonstrating that. And we also have this accumulator pattern, okay? So let's say demonstrate integer division and the accumulator pattern. Okay, that looks good. 2 blank lines. We define main, parens, colon. Let's put pass in it just to hold the place for a couple minutes. 2 blank lines. Call to main, parens, enter to get an empty blank final line. Okay, great. So, we said the first thing that we were going to do is we were going to initialize variables that need initializing. So I'm going to copy that from my already baked version. And you'll notice that even though in my pseudo code I kind of left a note for myself, initialize variables, okay, I didn't put that comment into my code because just like the last one, the genre I'm trying to get with my comments is less is more, okay? The way that we organize these programs is standard, okay? So after a while, when you're reading this and you look at this code, you're going to say, oh, Kevin's initializing his variables. Do I need a comment that says the same thing? I'm going to say not. Okay. Okay, so then 1 blank line. I'm going to go to the next part. What were we looking for? Well, again, we're looking for a loop. So we need a for loop that's going to do it number of pairs times. And then we're going to print a message. We're going to get the dividend and then get the divisor. So I'm just going to copy that block of code over. Okay, and you and I can take a look at it. Okay, so if we want to do a for loop, and let me make this a little bit bigger so it's a little bit easier to read. If we want to do a for loop, and we want to do it on the basis of we want to do it on the basis of a variable value, okay? Well, we need to, one easy ways to do is we can say for I in range, okay? And if we just gave it the number of pairs to collect, like if that were equal 5, then it would go around 5 times, but it would start with 0 and end with 4. And that's not what we want, okay? Because the message that we're going to print is going to be kind of neat. We're going to say now collecting integer pair, and then we're going to print I of pairs to collect, which is going to be 5. So the first time through, it's going to say now collecting integer pair 1 of 5, and then 2 of 5, okay? So to make that work in this range expression up here, we have to have 1 comma and not the number we want to stop on, because that's not the way range was created by the mothers and fathers of Python. It's one more than that. This is the first one we don't want. So we have to say pairs to collect plus 1. That to me is a pain in the ass, but that's the way Python works. And the people who invented Python and the real Pythonistas believe that's beautiful. I personally don't, but nobody asked me. Okay, so you can side with whoever you want to side with, but you have to add one here. Okay, I think it's an embarrassment that it works that way, but it does. Okay, so we're going to print a very sophisticated, polite message to say where we are. Okay, and then we're going to print. Oh, then we're going to collect the dividend. That's an int. The divisor. That's an int. Okay. Now, I guess this would be a nice place to test. Okay, we're definitely not done, but we could just throw in print dividend divisor. Okay, I can't emphasize enough when you guys are coding, you shouldn't go very far without stopping to test. Your computer is just sitting here lazily waiting for you to move the mouse or tap a key on the keyboard. It's got tremendous processing power, and it's being very patient waiting while you're doing nothing, okay? So put it to work, have it run a test. Let's run a test. Right click, run quotient accumulator. Now collecting integer pair 1 of 5. So let's say um, 5 divided by 4. Okay, 5, 4. Okay, 6 divided by 5. 6, 5. 7 divided by 6. That's good. 3 divided by 2. That's good. 2 divided by 3. All those things worked fine. So the code so far seems to be working fine. Okay. So you can stop at any point, throw in a print, do a test, just make sure your code so far works. Okay. All right. What were we going to do next? Well, we're going to do the processing inside the loop. We're going to calculate the quotient. Okay, let's do that. So, in fact, yeah, so we're going to calculate the quotient. That's right here. Sorry. Okay, so we're coming down here, and let's put that in. And of course, we have to indent that twice. Okay, that's fine. Okay, so we've got the quotient is equal to the dividend divided by the divisor. Okay, that's fine. And let's put in a little more code before we test. Again, what was in our pseudo code? Well, we want to produce the intermediate output, and we want to accumulate the accumulator. Now, here's where you begin to see that putting these comments into your pseudocode or into your code, where you try to show where the parts of this design pattern show up. Like for instance, this print is creating output, so this is part of output. But this accumulator, this is part of processing again. So should this have really gone up here? Well, a lot of times what we want to do is we want to add to the accumulator last. So this is why actually putting these comments that as kind of crutches to say which part of this design pattern are we in now. It can make your code, it can be burdensome. Okay, so here's what my real code looks like. Okay, my real code looks like this. Okay, I'm not dividing out the parts of the pattern quite so much. So I calculate the quotient. I print this quotient is a quotient period. Again, I can put a period at the end because this is a whole number. Okay, and then I I accumulate the accumulator. Now I could have said this. I could have said accumulator equals accumulator plus quotient. Okay. Instead, I've used the shortcut version where I've said accumulator plus equal quotient. Now, I wasn't a fan of this when I first learned this kind of shortcut syntax, but I'm a big fan of it now, and I think this is the best way to do it. Okay, now, are we able to test this? Yeah, I think we are. We're already seeing the quotient. That's good. Let's print the accumulator here too. Print accumulator. All right. Now, let's do some testing. Let's come down here and test again. Okay, so please enter integer for the dividend. Let's say 5 divided by 4. This quotient is 1, so we've accumulated 1. Now collecting integer pair 2. Please enter thing for the dividend. Okay, so let's say 4 divided by 3. That's 1 again. It's accumulated 2. And now the third pair, 7 divided by 6. Well, that quotient is 1, 2. Now we've accumulated 3. And then 8 divided by 7. Well, that's 1 again. We've accumulated 4. Okay, and then 9 divided by 8. Well, that's 1 again, and we've accumulated 5. So that's working great. Now, did we have to stop to test that? No, we didn't. But again, the smaller the piece of code that you put in before you run a test, the more you're sure of exactly where the error is if you have an error. Okay? So when you're starting out or when you're in code that you're not particularly sure of, take small bites. Okay? When you're more experienced or you're putting in code that you're used to, you're very sure of, well, then you can afford to take larger bites. Okay, so we don't need this print accumulator. That's a test code. Okay. Are we done? Well, let's look back at our pseudocode. That's the end of our loop. That's all the code that's under the loop. Okay, and then we need this final output. Remember, that's not part of the loop. See how we haven't indented it? So we want to skip a line, and then we want to print the accumulated sum of the quotient is whatever, and we want to use an F string to do that. Okay, very good. So I'm going to bring over the code that I've already coded to do that. Okay, so down here, and again, where are we? Where's the indentation? Well, it's not all the way out at the front. That's where the functions are. So it's one tab in. So I'm going to put it right there. So I'm going to use the print without anything in it to skip a line. Again, we'll have a more sophisticated approach soon, but not now. And then we print an F string. The accumulated sum of the quotients is accumulator, and then we put a period at the end. And then we're going to need 2 blank lines. Okay, let's run this one more time. Okay, so now collecting integer pair 1 of 5. Now, before I do this, if you're in this and you want to stop it, you can just click this stop button. Okay, and it looks ugly, but you stop. I was looking at the output, and I'd like a blank line in between each of the pairs. So how could I do that? Okay, well, I could do the following thing. I could say that instead of just putting a blank line before this final message, what if I thought of it the following way? What if I thought at the end of each of the groups I put out, I want to put the print there. So I'll put a blank line at the bottom of the loop. So I'm going to put a blank line after these groupings where we're collecting the pairs. And then, of course, I've got too many here. So I think that's going to do what I want. Let's see. All right, let's run it again. So pair 1, let's just say 9 divided by 8. The quotient is 1. And then 8 divided by 7. Okay. And then 7 divided by 6. You see how we're getting the blank line between the groupings? I think that looks really nice and user-friendly. And then 6 divided by 5. And then 5 divided by 4. And we say the accumulated sum of the quotients is 5. Yeah, and that makes sense. And it's all very pretty. Okay. Okay, so I think the only thing I haven't really called attention to here is the fact that I haven't included any of the pseudocode in my code, right? And I don't really have any comments, right? So this is from the less is more school of comments. Now, if you decide you need more comments in this, make sure that they state the intention of the code to follow and not just rehash a play-by-play of what's going to go on. You know, but here we can see that we've got initializing variables, a typical thing that goes on. And then we have a loop, okay, which has some input, some processing, and some output. And then we have some final output. And there's a lot of programs that are organized like this. For me, okay, I'm happiest with just the code, okay? No comments, definitely no pseudocode included in the program. And again, there's no commented code, right? I don't have like any code that I thought I might want, but then I wasn't sure and I put it into a comment. Okay, if you have anything like that, get rid of it before you hand in your work. Test it again, because every time you change your code, you ought to test it, even though you're absolutely sure you haven't broken anything. And then you're ready to hand it in. Okay, so that's it for this one. You're going to go off to do your own, which is different in a couple of ways. So pay attention to that. And I'll see you next time. Bye-bye.